Hi everyone, today we're solving problem 27. In this problem, we're first given a few quadratic formulas that when given values of n starting from 0, they produce prime numbers up to a certain value of n. What they next tell us is that taking quadratics of the form n squared plus an plus b, where the absolute value of a is less than 1,000 and the absolute value of b is less than 1,000, where n is the modulus / absolute value of n, we need to find the product of the coefficients for the quadratic expression that produces the maximum number of primes for consecutive values of n. So what we're going to do here is we're going to be iterating over the possible values of a and b, plugging values of n into the formula and seeing where the values are no longer prime. We're going to apply a few tricks to not have to go over all values of a and b, and we'll do that when we start implementing this. So let's go over and switch over to IntelliJ. The first thing we notice in this problem is that we can quickly eliminate possible values of b. We know that we're starting with n equals to 0, so let's see what happens when you plug in n equals to 0 into this formula. So we get 0, let me put this in the comments, 0 squared plus 0a plus b. And this just simplifies to b. And we know that it must be prime, so b is prime. So let's start by calculating all of the prime numbers less than 1,000. And these will be the possible values of b. So I already have the isPrime method from earlier videos. And what we're going to do now is calculate the range of values for which isPrime is true. So I'm going to do val primes less than 1,000 is equal to, and we're going to have 2, we know that's the first prime number, until 1,000, and we're going to filter is prime. And import that from util. Okay. I'm going to have to convert the number we're working with to a long because this isPrime method does require a long. So you're going to have to do n2 isPrime n not too long. Okay. So now we have the list of all primes less than 1,000. Now we're going to apply another mathematical trick. Let's see what happens when n is 1. So we get 1 raised to 2 plus 1a plus b. And this simplifies to 1 plus a plus b. And we know that this must be odd so that this number is prime. So therefore, a and b must both be odd or even. So a and b can both be odd, or a and b can both be even, but they can't be one is odd, one is even. So we can create a method def a values given b. And what we're going to do here is we know that the only value of b we're going to get that's even is 2. So if b equals to 2, then we want all possible values of a that are also even. So we know the lowest value of A that's even that we could use is negative 998, because it's between negative 1000 and 1000, not inclusive. And this is going to be until 1000, because that's our maximum, until, and we're going to go by 2. So we skip every 2, so then we'll get negative 998, negative 996, and so on. So we can actually get rid of these parentheses. And if B is not 2, then we have an else. And then what we're going to do here is we're going to start from negative 999, because that's the lowest odd possible value of A, until 1000 by 2. So this is going to do negative 999, negative 997, negative 995, and so on. So now we have a list of B values and A values that we can iterate through. Now let's do that. So I can do a for comprehension. So we'll go first over all possible values of B. So B in primes less than 1000. And given a value of B, we're going to go through all values of A and A values of B. Now that we have A and B, let's generate this formula. So I'm going to actually make a def calculate formula, which is going to take A, B, and N, and it's going to return the value given these parameters. So here we have n squared plus an plus b. So let's do this. So you have n squared plus an plus b. But given just b and a, we can actually use a feature of Scala called partially applied functions. So what we can do here now is we can do val formula is equal to calculate formula a, b. And notice that we're not giving a value of n, but formula is actually now a function from int to int. And now we can use this every time we need to calculate the value given n. Now let's calculate the number of values of n that work with this formula. So val count equals 2. And we don't need to check 0 because we already checked 0 with this case. And we already checked 1 with this case because we know that A and B are both odd or even. Actually, never mind. We didn't check. I don't know what I was saying. We have not checked the case where n is 1 because all we're doing here is checking that this is odd. We haven't yet checked that it's prime. So this is just eliminating cases that we know for sure won't work. The cases where this is even. But we do still need to check the cases where this may or may not be prime. So what I'm going to do is I'm going to do count is equal to, what I'm going to do is I'm going to create an iterator. And there's a method on the iterator object called from. And from takes a starting value. So we're going to start from 1. And I'm going to remove elements from this iterator using drop while. And drop while takes a function from int to boolean. So drop while is prime. So we need to keep on dropping while we have prime numbers. And is prime, we're going to give it math dot absolute value because our formula may produce a negative value, but is prime expects a positive value. So I'm going to do math dot abs formula of n. Okay, that works. Now, let me add a few lines here. So now that we have count, all that's left is returning a times b, which is what we're supposed to return in the problem. And we need to return how many of these were dropped. And we can actually calculate this, right, when we're calculating count. We know that if we dropped some values from 1 to the last prime that was produced by this formula, we just take the next value in this iterator and it'll give us the total count of primes produced. So we just do dot next. And we can do count here. We're going to be yielding values here. We're not just returning unit here. We want to store these values. I'm going to store these in val cases. And now all we have to do is println cases dot max by the second value, but we want the first value. So we're going to do underscore 2 here because that's what we're maximizing by, but underscore 1 because that's what we want to return. Now we can run. Okay, yeah, I forgot one thing here. We need to do underscore at the end to treat it as a partially applied function. Now I can run. And we get our answer, -59231. So that's it for problem 27. I'll see you next time when we solve problem 28.